Hello learners, welcome back to the course on construction methodology. This will be the last lecture of the entire course. I hope the learning so far has been wonderful and you guys have got enough knowledge, or let me say a basic understanding how the execution of the how the site execution is to be done. So in this lecture we'll try to summarize all the things that we have done so far, and I'll be explaining you that those things in a brief. We'll quickly get into that. Yeah. So before that, there's a channel on a YouTube by name Civil Brains. I request you all to go to the YouTube and please subscribe and like the videos that has been put up on my channel. So I request you all to please go to the channel Civil Brains and please subscribe to this channel. Yeah. So we know that a building is categorized into substructure and superstructure. So what do you mean by substructure? It's a part of a building below the ground level, like let us say PCC, or let us say footing and column up to the plinth level. All these are called as substructure. Next, what is superstructure? It's a part of a building that is above the ground level. For example, if I want to construct a ground floor column, or let us say first floor beam or first floor slab, all these things are above the ground level, or we can say above the plinth level. That is why all these things are called a superstructure. Yeah. So now we'll try to get into the sequence of the construction. So let us say you want to construct a house, or let us say you want to construct a residential building or a commercial building. So what is the process that we need to follow? So we'll try to see that. Or let us say you want to construct some commercial or some residential building. So these are the steps that we need to follow. So we'll try to get into that. So first is always we go for the soil testing, because let us say if you have to construct a small house and all, usually we don't go with the soil testing because the local contractor, and we know what is the SBC of a soil. I mean, even though we don't know, we know that if you go up to 1.5 meter, that is 5 feet, you're going to get a hard soil. So if you're constructing a small house and all, then we don't go for soil testing and all, right? Because a client cannot afford for all these things. But let us say you are constructing some G+5 buildings, or some G+10, or some high in a commercial and in a residential building. In that time, in that case, it is mandatory to go for soil testing. So a geotech consultant will come to the site. He'll take a sample of a soil and he'll do all the test on that SPT test and all, and finally is going to give a report saying that this particular soil have a capacity of, let us say, 150 kilonewton per square meter of SBC, or let us say 180 kilonewton per square meter of SBC. So this is the report that we are going to get. So once that is done, the next is to do the surveying, right? Because we should know what is the total area of our plot, and we should know the boundary of our plot, and at the same time, all these things will be done. Surveying will be done. Once the surveying and all is done, the next is the landscaping of a site, or clearing of a site. So why this has to be done? See, usually again, if it is a small house and all, usually there won't be a lot of debris and what you call filling and cutting. But let us say you want to construct a huge commercial uh, building, or let us say a huge residential building where you have 3-4 towers. In that case, you require a huge amount of land. So in that case, what happens? You are not going to get a level surface, right? There may be cutting in some place, there may be filling in some place, and there might be a lot of unwanted plants, trees and all. So in that case, what we have to do is we need to cut off all those unwanted plants, trees and all. And if there is filling, we have to do the filling, and if there is some cutting to be done, then we have to do the cutting. So all these things comes under landscaping of a site or clearing of a site. So once this is done, you're going to get a plain surface where you'll be having a good amount of soil, and you're going to get a level surface. So after that, we'll start with our normal procedure. The first thing is always we go for foundation center line marking or a grid line marking, because whenever we execute some project, the first drawing that we are going to get is of course the architecture plan you are going to get. Once you get the architecture plan, the next is we get the footing layout. We'll try to see that. So this is how a footing layout looks. Yeah, I'll open that. Yeah, so this is a footing layout. You can see it here. It's a foundation layout. So all these are the grid lines. A, B, C, D, E are the grid lines. Similarly, 1, 2, 3 are the grid lines. So based on first what will happen, we are going to mark all these grid lines, and then we are going to mark the center point of this particular footing. And from the center line, all these offsets will be given. All these offsets will be given. So based on that, what will happen? We'll do the marking of this entire footing layout. So this is the first step that we are going to do. So once this marking is done, Next is foundation, center line marking, and grid line marking. Next is what we are going to do. We are going to do the excavation of the footing, right? Once you have done the marking, the next step is to do the excavation. So while doing the excavation, again, it will be mentioned in the drawing that how much depth you have to go. Let us say if it is a small building and all, usually we go for 5 feet until we get a hard soil strata. Let us say 5 feet, or let us say 1.5 meter. But if it is a big structure and all, in that case, it depends how much the geotech consultant has given. Let us say you have to go up to 2 meter or 2.5 meter below the ground level. So this is how it is done. So that is called as excavation of the footing. Like once the excavation is done, next what we are going to do, leveling the soil after excavation with labors and compactor, right? Once you done the excavation, you're not going to, I mean, once you do the excavation, you're going to do with the help of a excavator, or let us say JCB, right? So what will happen, you're not going to get a uniform surface, right? So because of that reason, what we are going to do, we are going to deploy 1 or 2 labors into that particular pit, footing pit, and we'll ask them to level that particular pit, so that if there is some let us say JCB cannot, let us say you want to do 1.5 meter of excavation, and JCB has done almost 1.4 meter, another 100 extra is left out. So with the help of a labor, we are going to remove that another 100 with the help of a pickaxe, and these laborers are going to do that. Once that is done, with the help of a plate compactor or a monkey rammer, what we are going to do, we are going to compact that, because see, before the excavation happened, your soil was in, and it was in an undisturbed soil, I mean, it was an undisturbed soil, and it had enough density over that because of the over consolidated uh, pressure. What happened, it had enough density in that. But once you did the excavation, what happened is it became a loose soil, right? It became a loose soil. So because of that reason, what we do the compaction, so that we get enough density there with the help of a plate compactor or monkey rammer. The second reason is to get a uniform surface, so we have to do a plate compactor or monkey rammer. These are the instrument that we get. We have to run it over that particular area. Once that is done, the next is the laying of PCC. So PCC stand for plain cement concrete. In this, we are not going to use any rebar or reinforcement bar. It's just a concrete that we are going to pour, but it has a grade. Usually we go for M7.5 or M10 grade of the PCC. If it is M7.5, then the ratio is 1:4:8, and if it is M10 grade, then it is 1:3:6. And usually the thickness of the PCC, usually it is 75 to 100 but again it depends. Sometimes you can go up to 150 also, but usual practices we go for 75 or 100 thickness for the PCC. Again, PCC is given to get a uniform surface, and there is no much technical in that. So once the PCC is laid, the next is marking of column center point and preparing the column layout. So what do you mean by this? See, again, once the footing is marked, you'll call the surveyor, or with the help of a tape, we are going to mark the center point of the footing and the column, so that you can keep your footing mesh and the column reinforcement. For that, what we have to do, again, you have to refer the same footing layout drawing. You have to mark this center point, and now at the beginning we had marked. Either with the help of plumb bob, you can transfer that level to the bottom of the to the top of a PCC, or again you can call the surveyor. If you're working in big projects, we call the surveyor, and the surveyor is going to give this particular center point. Again, we are going to do the marking for this, so that we can place our footing mesh here. Yeah, so it's written marking of column center point and preparing the column layout. That means, so for preparing the column center point and preparing the column layout, we need to refer another drawing that is called as column layout. Yeah, this is a cross section. I'll come back to that later. Yeah, so this is a column layout. You can see it here. It's written here column layout, and it's written here column layout and reinforcement details. So this is again the once a footing layout is done, while keeping the center point, we have to go to refer this column layout. Again, these are the column layout. You have this again grid lines A, B, C, D, E are the grid lines. 1, 2, 3 are the again the grid lines. So these are the column locations. I mean, these are the locations of the column. All these are the locations of the column. You have the name of the column as C3, C1, 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 C2, and whatever column you have, the same dimensions will be mentioned here. You can look here. So this is C1 column. How many numbers are there? There are 4 numbers of C1 column. What is the size of this particular column? It is 10 inch by 1 feet by 6 inch. 10 inch comes out to be 250 mm, and 1 feet 6 inch comes out to be 450 mm. So all these things will be mentioned here. Along with that, how many bars you have to use in that particular column. You need to use 12 diameter 12 bar, 8 12 diameter 8 bars, longitudinal bar 16 diameter 12 bar, 12 diameter 12 bar. All these things will be mentioned here. Along with that, what is the lateral ties that you need to use, and how many diameters of the which diameter of the lateral ties you need to use, that is mentioned here. That is, this represents you have to use 8 lateral tie, and the center to center spacing is 7 inches. 7 inches comes out to be 175 yeah. And same thing is here. Again, you have to make use of 8 lateral ties. These lateral ties are made, I mean, they are made with the help of 8 bar, and the center to center spacing is 8 inches. These things already I have explained while explaining the column reinforcement details. So again, this drawing we have to refer. Again, we have to do the marking. Yeah. So once that is done, next is placing of footing mesh along with the cover block in bottom and sides of the footing. So what will happen once you've done the center point marking, you're going to place the footing mesh, right? Because for footing mesh, what you have to refer again, you have to go to the footing layout. This is a footing. Here, those cross sections will be given, like what diameter of a bar you have to use. Let me go through this. You can, I'll explain it here. And now in the videos, I've explained it. So let us say this is a plan. Okay, so it's mentioned here the size of this footing is 6 feet by 7 feet, right? Yeah, this is 6 feet and this is 7 feet. It's mentioned here, and it's mentioned here in the bottom you have to use 12 diameter bar, and the center to center spacing of this bar should be 8 inches. And here again at the again this bottom you have to use this side. So this was this way, and this is in this way you have to put, right? Always remember the shorter span bars are put first. So out of 6 feet and 7 feet, 6 feet is less. Yeah, 6 feet is lesser compared to 7 feet. So this horizontal bar will be placed first, followed by this vertical bar, right? Yeah. So again, here you need to provide 12 diameter bar, and that center to center spacing is 5 inch, right? Because since you're going to place shorter span bar first, that is why the spacing is 5 inch here. Whereas the distribution bar, what you can get here, that is 8 inches here. Again, it depends how you are going to design it. So based on the design, we have got this, right? So similarly, all these are the cross sections that we get. Based on this, we are going to mark the center point, and we are going to prepare the footing mesh. So once the footing mesh is placed, always we have to always remember that we have to keep the cover block, right? It's cover block in the bottom and the sides of the footing. Again, the importance of cover block already I mentioned in my lecture, in order to avoid it from corrosion and from fire resistance point of view, and also to give a good bond between the rebar and the concrete. We are going to use cover block. So usually 50 of cover block is used for footing, but sometimes that can go up to 75 for a severe condition. Again, that depends on the durability condition. To refer IS 456, it's mentioned there. But most of the case, what we do is 50 But if you're putting up a structure in some when it is exposed to sea and all, when it is let us say it is inside the water and wall, in that case you have to go for more cover block, I mean more clear cover, that is of 75 This is for the extreme condition. For general nominal, what we do is 50 right? Once this is done, the next is placing the footing shuttering of a required size. Let us say the footing is let us say for this, let us consider the same footing. So this is 6 feet by this is 7 feet. For this, we need to place the shuttering, right? Only after placing the shuttering we can pour the concrete, so that this particular shape is obtained at the side. So I'm going to place a 6 feet of shuttering on this side and 7 feet of shuttering here. So once this is done, the placing of footing shuttering of required size is done. Once that is done, next is what you have to do: placing of column reinforcement and a column cage on the footing mesh, right? So this should have come first, I guess. Yeah, this should have come first, followed by this. It's not an issue. So when you're placing the footing mesh and column reinforcement, those will be put up together. It's not that footing mesh will be put first, then you're going to pour the concrete, and after that you're going to keep the column reinforcement. That is not going to happen, because there should be a fixity between the footing mesh and the column, right? That is why when we do the ETAB design and all, we are going to give a fixed support at the base. So that is why in the footing mesh and this column reinforcement, you are going to put it at once, and only then we are going to cast the footing. So once this is done, next is pouring of concrete in the footing of a required grade, as mentioned in the drawing or in the footing layout plan, right? Once you have done the shuttering and all, the next is to pour the concrete into that particular footing. And whenever you pour the concrete, you have to see the drawing again. Usually you're going to use single grade of concrete only. So in the drawing, it will be mentioned what grade of concrete has to be used. We'll try to see that. So it will be mentioned here. Yeah. it is if you can observe it here, the grade of concrete shall be M25 with 20 downgraded aggregates, right? So it's already mentioned here. So in this particular footing, I mean in this particular structure, you have to use M25 grade of concrete in the footing, column, beam, and everywhere. So it's everything will be mentioned in this general notes. Based on that, we are going to do the execution. Yeah, we'll go back to that again. Yeah, so pouring of concrete in the footing of required grade has mentioned in the drawing or in the footing layout plan. Yeah, once this is done, next is what you're going to do. Once you're done with the casting of the footing, next day we have to come and we have to do the de-shuttering of a footing of a next day, and you have to do the curing of that particular footing, right. See what you're going to do. Once you're done the casting of the footing, let us say now you're done the casting of a footing. So tomorrow you are going to come at the same time. After 24 hours you are going to come, and whatever shuttering plates you had kept for the footing, that is a vertical I mean the sides of the footing, that you are going to remove that. That is called as de-shuttering of the footing. So we have to usually what we follow is we wait for 1 day, and after 24 hours or 1 day, we remove those vertical shuttering. I mean we remove those shuttering. So once the shuttering is removed, immediately we have to do the curing, right? Curing of footing for 7 days minimum after de-shuttering, and place a gunny cloth over it to absorb the water. So what do you mean by this? Once you remove the shuttering, what we have to do? We have to pour. We have to do the curing of a footing, right? Because we have seen what is the importance of doing curing. So usually what we practice is up to for a week we have to do the curing for the footing, and along with that, if possible, we can put a gunny bag over the footing, so that that particular area will be kept wet. Yeah. So once the curing is done, next what we have to do? Next is preparation of the column starter for placing of column shuttering starter frame to be kept ready, right? So once you're done with the footing, the next is you have to raise the column, right? You are in the ground floor now. I mean, you are in the footing now. From there, you have to come to the ground level. Up to the ground level, what we have to do? We have to do the casting of a column. For casting of a column, first what we have to do? We have to do the column starter. Once you put the column starter, only then you can keep your column shuttering. Otherwise what will happen, it will be difficult for you to align the column shuttering. That is why we put a starter concrete of usually 75 or 100 thickness, so that it will act as a base for that particular shuttering. So this starter frame to be kept ready, so usually you get a starter frame. Let us say you have a 200 by 300 size of a column. The starter frame also will be of 200 by 300 that we are going to place into that particular column, and then we are going to put the starter concrete. So once this is done, next is placing of column shuttering and keep checking for the plumb. So once you put a starter concrete and you raise the and you put a column shuttering box, so what you have to check? You have to check for the plumb of that one, because it's a vertical element. So when I cast the column, I want my column to be 90 degree. I mean, I want that column to be vertical, right? So I cannot make my column inclined. So if I make it inclined, then the load transfer will not happen according to my analysis or design. So that is why once you put up a column shuttering, you have to check for the plumb, so that you're going to get a vertical uh, I mean you are going to get a 90-degree angle to that. I mean you need to get a straight column, right? So that is the importance of checking the plumb. So be careful while placing the column shuttering. It should be properly aligned vertically. Always whenever you put up a vertical element like column, box and all, you have to check for the plumb of it, so that it is 90-degree. Next is check for the cover blocks in the column before pouring of a concrete. Check the grade of a concrete to be poured for column, since column grade may be different from beam and slab concrete. Yeah, this is a very good point. Actually what happens, yeah, once you put up a column shuttering box, the next is before the pouring of a concrete, always make sure you have given enough cover block. We have seen the importance of cover block. That's the first thing. Second is that usually when you work for big projects and all, usually I mean usually what we do is, in not in most of the case, in few cases what we do is, for the footing, for the beam, for the slab and all, we keep same grade of concrete. But when it comes to column, we are going to increase the grade of concrete. That means, let us say I'm using M25 grade of a concrete for a footing, for beam, slab and all. But when it comes to column casting, I'm going to increase the grade. Instead of M25, I'll mention it as, for column you need to use M30 grade of concrete. Now what is the reason behind this? See, usually column is my compression member, and we know that concrete is strong in compression. So by taking the advantage of that, what we do is we increase the grade of a concrete, in particular in case of column, so that you don't have to provide more reinforcement into that. or let us say you want to let us say while doing the analysis your this thing column is failing. So in that case, with the help of ETABS, let us say I mean your column is failing. So in that case, what we can do is we can increase the grade of the column. This is usually what we do. Not in all the projects, it depends on the designer how he is going to design. Otherwise, you can keep the same grade, like what you can see here. Here what they have mentioned, grade of concrete shall be M25 with 20 downgraded aggregate. That is fine, because here everywhere you are using M25 only in the footing, in the column and all. Just in case, let us say you want to use M30 grade of concrete in column, then when it comes to column, like either he'll mention it here, column layout, and he's going to mention here M30 grade of concrete, or in the general notes itself, he has he can mention it here, grade of concrete shall be M25, and a grade and in the notes he can put in a bold letter, he can make it as grade of concrete to be used for column should be M30. This is what he has to mention it here. Whatever you are going to design, the same thing has to be mentioned here, because the same thing should be executed at the site, right? Because by doing on ETABS, you just, that is analysis and design you are going to get, but whatever you are doing, that has to be implemented, and that implementation will happen only when you mention it in these drawings, so that the site person or the contractor is going to execute the same thing on the site. So usually people don't, I mean sometimes they do, but even though they do, they'll mention it here, because again what will happen, there will be a discrepancy at the site. I mean a person may not be good at reading the drawings. So what will happen, he will pour M25 grade in column also, in beam also, in footing also. So whatever the design engineer has designed it, the same is not being executed at the site. So usually we try to avoid it. In worst condition we can do that. Yeah. So once that is done, and cover block, usually for column we are going to give 40 and in few cases we can give 25 that is, yeah, 25 So when this case will come, already I have explained it. You have to refer IS 456 2000 code book. It is mentioned there, if a size of the column is less than 200 and longitudinal bar that you are using is less than 12 in that case the code allows you to make use of 25 clear cover for the column. Again the code mentions can can be used, so it's not telling must be used, right? If you want, you can use it, otherwise you can go with 40 only. There is no issue with that. So once that is done, column casting will be done till plinth beam bottom only, and make no mistake here, right? So always whenever we do the column casting, always whenever we do the column casting, it will be done till the bottom of the beam. Either it is a plinth beam or let us say roof beam, because let us say height of the column is 3 meter, so that entire 3 meter of the column will not be casted at once. What we do is, from there we are going to deduct a beam depth. Let us say you have a column of 3 meter, and there is a beam which is intersecting that, having a depth of 450 So now this particular column will be casted up to the beam bottom. So what you have to do, 3 meter minus 450 that is 0.45, it comes out to be 2.550, right? Yeah, 2.550. So this column will be casted only up to 2.550 meter height, so that the beam bottom will match to the top of the column, and you can place your column, I mean, yeah, beam reinforcement over there. Otherwise, if you're casting entire 3 meter, let us say, then you cannot even though you keep your beam bottom, where you're going to place your beam reinforcement, that can, because your beam reinforcement and your column reinforcement has to be a fixed support, yeah, but only then the moment will be transferred to the column. So in order to achieve that, what we do is, we always cast the column up to the beam bottom, and slab and beams are casted at once, that is called as monolithic casting, whereas column is casted first, and after that beam and slab is casted. So always remember, whenever you are going to do the column casting, always cast it till the bottom of a beam. Even if you cast 100 or 150 less than the beam bottom, it is good. Never cast it beyond that. That means if 2.55, let us say 2.550 is what I told, that is the level you need to do the casting. Instead of doing 2.550, you can cast it up to 2.45 also. There is no issue with that, because the remaining amount will be done along with the beam and the slab casting, right? But never try to do it more than 2.550, because even if you do that, tomorrow you have to do the chipping, that's it. So again you have to put in labor, and you have to do the chipping and all. So instead of that, always try to do to the same level, I mean up to the beam bottom, or even 50 or 100 below that is also good. It's fair enough, not an issue with that, right? So once that is done, deshuttering of column next day, followed by curing immediately for 8 days, right? Once you're done with the column casting, again you have to do the curing of that. Usually up to 7 or 8 days you can do the curing of a column. Make sure the columns are covered with the gunny bags while covering. Gunny bags will help in absorbing the water and holding water for a longer duration, right? We know that. Again, I will not try to get into this again. Again, once you're done with the curing, you have to wrap the entire column with the help of a gunny bag, so that the curing is happened. And usually when you work in big projects, what we do is, once the column is casted, we are going to write the date on that particular column. Because once you work in the big projects, you will not have, like, if it's a small house and all, you will have hardly 15, 20, 25 columns, let us say. That is not an issue. But if you work in big companies and all, you will have more than 100, 150 columns. In that case, what will happen, you never know which column was casted on which day. And let us say your site manager has entered your site, and he can't keep on asking you or some laborers when was this column casted, whether the curing is being done on a daily basis or not. So it's always a good practice that you write the date of the column, I mean, yeah, date on the column on which date was casted, so that even anyone enters your site, he'll come to know that this column was casted on that particular day, and the curing is being done on a daily basis. And that this is how it happens at the site. So once that is done, next is backfilling of a soil up to the ground level, right? See what we did actually. We started the excavation. From there, we went all down. We did a PCC, we did a footing, we put our column, and we have reached up to the ground level. So whatever soil we have excavated from there, we have to backfill it, right? Only then you are going to reach the ground level, right? So what we are going to do, backfilling of soil up to the ground level. Backfilling of soil should be done in layers, as mentioned in the BOQ. BOQ stands for bill of quantities, and proper compaction watering should be done after each layer is backfilled. What do you mean by this? See, let us say you're done 1.5 meter of excavation. So 1.5 meter of excavation, when it is done, you cannot backfill the soil at once. Like you take bring in an excavator or bring in a JCB, and you tell him to backfill all the soil at once. That is 1.5 meter of soil will not be backfilled at once. If you do like that, then the settlement of your footing will happen. So usually what we do is we fill it in layers. That is why it is mentioned here, soil should be done in layers. So what we do, we bring the soil, we pour it into that particular let us say 1.5 meter of excavation. We are going to fill it in layers. Let us say 300 I'm going to fill the soil. Then I'm going to do the compaction with the help of a earth rammer and with the help of a plate compactor. Then that is called as compaction. Then I will pour the water into that, so that the consolidation will happen, and then I'll allow the water to stay there overnight. Next day I'm going to come, I'm going to do the compaction again. Then again I'm going to pour another 300 or 200 of the soil. Again I'm going to do the compaction. Again I'm going to allow the water to stay there overnight. So this is what we practice. Because the soil which was there initially, what happened, it was undisturbed soil, and it had enough density in that, right? It had enough density in that. Once you started to excavate the soil became loose, right? The soil became loose. As a result of that, what will happen, it will not have enough density, because ultimately the entire load of your structure should be taken by a footing, and from the footing it has to be transferred to the soil, right? Even if your soil doesn't have that capacity to transfer, then that load will never get transferred. So that is why always a compaction has to be done. And along with the compaction, we do consolidation also. That is, will allow the water to stay there, so that what will happen, whatever density we require, that will be achieved. So those things also we saw, we have learned it from geotechnical engineering, where optimum moisture content and maximum dry density of 95% has to be achieved, right? We have plotted a graph, and all we saw what is OMC and how much maximum dry density has to be achieved. So even those tests we do at the site, once we do the backfilling, and once we do this what you call consolidation. Yeah, we'll not try to get into that again. Yeah. So once that is done, next is preparation of plinth beam PCC, right? Once you fill the soil up to the ground level, we have to do the plinth beam PCC. So what you are going to do, you are going for preparation of the plinth beam PCC. The plinth beam PCC will be either 75 or 100 of M7.5 or M10 grade. An offset of 75 or 100 is taken extra for plinth beam PCC as working space. So what do you mean by this? We are going to put a plinth beam PCC. Once when we put a plinth beam PCC, the thickness of the PCC will be usually 75 or 100 Some engineers give it as 75 some engineers give it as 100 So whatever is mentioned in the drawing, the same thing we are going to follow it. And the grade of a PCC will be usually M7.5 or M10 grade. When yeah, M7.5 or M10 grade. And you have to be careful here. An offset of 75 or 100 is taken extra for plinth beam PCC has working space. What do you mean by this? So let us say this is my plinth beam layout. Again, this is a drawing what we have to refer for plinth beam. It's written here plinth beam layout. And what is the size of this plinth beam? It is P stand for plinth, B stand for beam. One is a first beam. It's again 10 inch by 1 feet by 6 inch. That is 10 inch comes out to be 250 mm is your width. And your depth is 1 feet by 6 inch. 1 feet by 6 inch is 450 mm is the depth of your beam, right? So what is trying to tell, whenever we put a plinth beam PCC, we should take another 100 mm extra or 75 mm extra on either side. Yeah, so let us say what is this? 10 inches the width of the PCC, I mean the width of the beam, but for PCC you have to take another 75 mm extra. 70, let us consider 75 mm extra. 75 mm comes out to be 3 inches. So instead of putting this plinth beam PCC of 10 inch, we have to add 3 inch extra on either side. That is 75 mm is 3 inches. So 3 inch extra on this side, 3 inch extra on this side. So total what will be this? 6 inches. So this particular size will be 10 inch plus 6 inch. It comes out to be 16 inches. You have to put a PCC of 16 inches, so that when you keep this beam reinforcement and you're going to place the shuttering for this particular beam, this extra offset what you're taken on either side, it will act as a level surface to keep this shuttering board. Otherwise what will happen if you don't give an offset, and if you put a PCC of 10 inch only, where you're going to keep your shuttering board for this particular beam? Because you can keep the shuttering board, but you're not going to get a uniform surface, right? Your shuttering board may go down here, it may come up here. So in order to get a uniform surface, what we do is on either side, here and here, we are going to put 75 mm extra, that is 3 inch extra on either side, so that your shuttering board can be kept exactly on this level, and you're going to get a uniform surface. So that is what written here. Offset of 75 or 100 mm is taken extra for plinth beam PCC as working space. Next is placing of plinth beam reinforcement. Once you have put up a plinth beam PCC, next what we have to do, we have to put up the plinth beam reinforcement. Again, you have to refer the plinth beam layout. This is a plinth beam layout, and this is the reinforcement details what you get. It's written here. Plinth beam sections and RC details. So this is a section for a plinth beam. In this particular plinth beam of PB7, which is 10 inch by 2 feet, that is 250 mm by 600 mm. You have to use 12 diameter 3 bar at the top. You have to use 12 diameter 3 bar at the bottom. And the stirrups that you need to use is 8 mm stirrup you need to use, and 5 inch is the center to center spacing. 5 inch comes out to be 125 mm, 125 mm. So this is a cross section of that. That is 1, 2, 3 bars you can see at the top. That is why it is written here 3. But if you're seeing from a longitudinal point, you're seeing it from front side, so you're going to see only one bar. But in the cross section, you'll try to see all the bar. It is 1, 2, 3 at the top, that is 12 diameter 3 bar you need to put. Again in the bottom, 1, 2, 3, you need to provide 12 diameter 3 bar at the bottom. And what is the stirrup that you need to use? You need to use 8 dia stirrup. And what is the center to center spacing? It has to be 5 inch, that is 125 center to center spacing. So in this way you are going to get a typical plinth beam details, RC details. Based on that, all the reinforcement will be arranged here, right? Anyhow, I explained all these things in the lecture. You can watch it from there. Yeah. So the concrete, once that is done, yeah, this is done. Placing of plinth beam shuttering. Yeah, once the reinforcement is arranged, what we have to do? Again, we have to do the shuttering for the plinth beam. Again, we have to do the shuttering for the plinth beam. So once the shuttering for the plinth beam is done, next is concreting of plinth beam. Make sure the dimensions of plinth beams are checked properly and see to it that cover blocks are given again. Again, before doing the concreting, make sure the cover blocks are given. Again, whatever is the dimension of this particular plinth beam, let us say this is the dimension of the plinth beam, the same size of the shuttering is put up. That is, the width will be 10 inches, and your depth will be 1 feet 6 inches. So 1 feet 6 inch of shuttering board, and the distance between this and this shuttering board, that is the width of the shuttering board, will be 10 inches, that is 250 mm. So this is how we are going to arrange the plinth beam. Yeah, once that is done, once we are done the casting of a plinth beam, the next step is deshuttering of plinth beam after a day, and immediately curing will be started and continued for a week, right? Again, you've done the casting, next day again it's a vertical element, so the code recommends you to deshutter the vertical element after 24 hours. That is, the time limit is 16 to 24 hours, but usual practice is we remove it after a day, that is after 24 hours. So deshuttering of a plinth beam after one day, and immediately curing will be started and continued for a week. Again, you have to do the curing. So once again, plinth beam is casted. Next, what we are going to do, backfilling of plinth beam inner side with a good soil and compacting it with the earth tremor. Again, the same thing, because we up to the ground level you have put the soil. Again, from ground level you have raised the plinth level. Let us say the depth of the plinth beam is 450 mm. Again, 450 mm of hollow. I mean, you're going to get a what you call, there's a hollow in between the plinth beam. That hollow space has to be filled up by the soil. Again, the same procedure. You have to in this case you can fill it in one layer, because the depth of the plinth beam will be usually 300 or 450 mm. So 300 mm or 450 mm of soil can be filled at once, and you have to do proper compaction and proper compaction with the help of a plate compactor or monkey rammer, and you have to do the consolidation, so that you're going to get a good soil. Again, it's mentioned here, with a good soil, right? Usually what happens, when you do the backfilling, let us say you're working on a site and you're encountered with a black cotton soil, which is not a good soil for a engineer, because black cotton soil is good for growing of cotton. For a civil engineer, a black cotton soil is like a nightmare, because it will shrink and it will swell like anything. So usually we don't recommend using a black cotton soil. So let us say you encountered a black cotton soil in your construction site. What we are going to do is, we are not going to use the same soil for the backfilling. We'll order a good amount of soil from the outside, and we are going to do the backfilling of the soil. Yeah. Once that is done, again, placing of ground floor starter for the column. So far what we did is, we raised up to the plinth level. From there you have to raise the ground floor columns, right? For raising the ground floor columns, again you have to put the starter concrete. So it's written here, placing of ground floor starter for the column. The starter frames are kept ready for the column dimensions, and starter concrete is placed. Again, it's the same thing, you can understand it. The column reinforcement are tied up to the first floor, and lateral ties are also spaced at proper spacing as mentioned in the column layout and column steel drawing. Again, it's the same thing. Again, you have to raise the ground floor column reinforcement up to the first floor. You have to put all the lateral ties. Again, you have to refer the column details. Again, those things will be mentioned in the drawing. The same has to be implemented at the site. Again, the shuttering for the columns are placed, and make sure the cover blocks are given. Again, it is 40 mm. The shuttering box for the column should be oiled before placing the concrete into it, right? Always whenever we put the shuttering box, always shuttering, we have to make sure that oil is placed, oil is applied to that, so that when you do the de-shuttering, it will be easy for us to remove that. Next is, the concrete required for the column is ordered from RMC plant. Usually when you work for a big projects, you order it from a batching plant, that is RMC plant, ready mix concrete. Otherwise, if you're working for a small project house and all, the local contractor will make it ready with the help of a concrete mixer, and is going to place it. While pouring the concrete into the column, make sure the height of pour is not more than 1.5 meter, and proper use of vibrators should be done after each layer of concrete is placed. The column casting is done till beam bottom only. Again, we have seen this. So what is trying to tell, whenever we pour the concrete, let us say height of your column is 2.5 meter. So the usual practice is, we don't put it at once. In a layers, we are going to fill it up to 1.5 meter. We are going to pour the concrete today, and tomorrow we are going to raise another 1 meter. That 2.5 meter is what we need to cast, let us say. So 1.5 meter is done today, and tomorrow we are going to do another 1 meter. So that what will happen, this clause what is mentioned here should not be more than 1.5 meter, because if you're pouring it more than 1.5 meter, usually segregation will happen, and proper compaction may not happen. As a result of that, you're going to get a honeycomb structure. So in order to avoid all those things, what we do is, the usual practice is, we are going to put it in one or two lift. This is what is trying to tell. And you have to make use of the vibrator, so that you get a uniform mixture, and so that honeycombs and all are avoided. Yeah, once that is done, again, de-shuttering of column next day, followed by curing for a week. Again, you have to do the de-shuttering, then again you have to do the curing of the column. So once that is done, once all that is done, next is what we have to place the first floor, or let us say first floor beam bottom, right? See, in a plinth beam, you didn't want to put a beam bottom, because your PCC was there, and over the PCC you have to put a concrete for the plinth beam. Whereas for the first floor, let us say, you have to put a beam bottom, because see that you don't have anything there to support that. So what you have to do is, you have to put a beam bottom, and once you put a beam bottom, you have to put a beam sides, and then we are going to place the reinforcement. So it's mentioned here, arranging the beam bottom with props placed at equal distance apart. The ground floor beam details have to be followed to get a size of the beam. Again, you are going to refer the drawing. This is plinth beam. After plinth beam, you are going to get the slab details, ground floor slab layout, and along with that you are going to get the beam details also. Yeah, this is how the beam details you are going to get. These are the beam details for the ground floor. That is, you have to provide a 20 diameter bar 2 at the top. Near the support, you need to provide 20 diameter 2 bar, and in the next layer you have to provide 20 diameter 2 bar, again 20 diameter 2 bar. and the stirrups has to be spaced at 5 inches near the support, 5 inches near the support, and 10 inches at the center. So these are the reinforcement details that you get for the beam. So like looking at this particular reinforcement details, we are going to do the reinforcement arrangement to the floor beams. So arranging the beam bottom, once you arrange the beam bottom, next is arranging the shuttering for the beam inner sides and the outer side, right? Because again, you have to, once, if you want to pour the concrete into that, you have to put the shuttering. So beam bottom is done. Along with the beam bottom, beam sides you have to put up, beam inner sides and beam outer sides. So placing the wooden or steel props and placing the slab centering plates of the required size. Once the beam bottom and beam sides are put up, next is you have to put up the slab centering plates. You'll put up the slab centering plates, and proper props are used there, so that you are going to get a what you call enough strength to that particular slab centering plates. Next is preparing the beam reinforcement of that beam and tying with the binding wire at the location of the slab. Again, it's the same thing, you have to refer this drawing. You are going to get a reinforcement details of that particular beam. So based on that, we are going to tie the beam reinforcement. So the beams are arranged as primary beams and secondary beams, and they are arranged in the same way so that the lowering of a beam will be easy. So what do you mean by this? So we'll try to understand this. So there are two beams. We have primary beams and we have secondary beams. So primary beams are those beams which are resting from, which are resting over the column. Let us say you have two column, and on both this column your beam is resting. Then your beam is called as primary beam. Now let us say you don't have any column, and your one beam is resting on the other beam. So in that case we call that as a secondary beam. Or let us say on one side of your beam is resting on a column, and other side of your beam is resting on another beam. So even in that case, what happens, that becomes a secondary beam. So the usual practice is the primary beams are laid first, and over the primary beams we are going to give the secondary beams. And always remember, when we do the analysis using ETABS or StatPro, usually what happens is the secondary beams are made as simply supported. So that means when I say simply supported, that means I'm not going to give a development length to that particular beam. Only the my idea will be only to keep the beam over that. So that why we do that, why we do the secondary beam simply supported, because if I'm giving it as a, if I'm giving a development length to that, and if I'm trying to make it as a what you call like a main beam, or if I'm trying to give a development length, what will happen, the secondary beam will try to create torsion in the primary beam. And if a secondary beam is trying to create a torsion in this sorry, yeah, if a secondary beam is trying to create a torsion in the primary beam, then your primary beam has to be designed for the torsion. And again, that becomes a tedious work for a designer. So in order to in order to make it easy, what we practice is we make the secondary beam has simply supported. So by doing that, once you're making it as simply supported, we know that near the support the bending moment is zero. As a result of that, there is no torsion being created on the primary beam, right? Again, it's a designing concept, we'll not try to get into that, but always remember, the secondary beams are made simply supported so that the torsion is not created in the primary beam. So the beams are arranged as the primary beams and secondary beams, and they are arranged in the same way so that lowering of a beam will be easy, right? So once that is done, the beam reinforcement are then lowered down into the respective beams after the reinforcement checking is done by the site engineer or the quality engineer. So what we do, with the help of a runner, we are going to keep all the beam over the slab shuttering, and then we are going to tie it with the help of a binding wire, and a site engineer or a quality engineer will come and is going to check it based on the drawing whatever we have given. This is a drawing what we have, right? So the engineer will come and try to see whether this guy has given 16 diameter 2 bar at the top or not, whether this guy has given 20 diameter 2 bar in the bottom or not, whether he has given 20 diameter 2 bar at the second layer or not, whether the stirrup spacing is 8 inches here or not, whether it is 10 inches or not, whether it is 8 inches or not. So he's going to check each and every of, I mean, usually he don't check each and everything, but he'll try to have a look over all these beams, whether the contractor or the bar bender has done it properly or not. So once he has checked everything, the next is the beam reinforcement are then lowered into their respective beams after the reinforcement checking is done by the site engineer or the quality engineer. Next is how to put the beams down, put the beam reinforcement into that respective beams. So once the beam reinforcement are lowered, the next task is to mark the slab reinforcement spacing and position of the crank bar, right? So again, we have to put the rebar to the slab, and wherever the crank has to be put, we will do the marking and all. Again, for that we need to refer slab layout drawing. So this is a slab layout drawing. Again, it's ground floor slab layout. You have to provide 6 inches thick slab, that is 150 mm. So these are the reinforcement details you're going to get. We'll try to see this. So this is a typical cross section of a, slab. It is mentioned here you have to provide a 10 diameter bar which is spaced at 8 inches, and you have to provide 8 bar 6 inches, that is a distribution bar. So it is shown in this way. Okay, but usually what happens is we are not going to get each and every details regarding the slab in the drawing, because in the site we practice in a different way. Okay, so usually the engineers try to give you a bottom and the distribution bar, whereas how much the crank has to be done, with which how the crank bar has to be put up, all those things will be executed at the site by a site engineer, and a barbender knows well how to do all those things. So if you are referring a slab layout or a slab reinforcement details, you're going to get only the bottom and the top bar, and sometimes if the engineer is good, he's going to give that cranking distance. Otherwise all those things we are going to do at the site. So a bar bender and a site engineer knows that better. Based on that we are going to do that, right? Yeah. So the slab layout and the slab reinforcement drawings are referred here for proper understanding of the reinforcement details. Once all the bars are placed for the slab, the bar bender with the help of a lever will crank every alternate bar so that detailing criteria is satisfied. For this I have put up a video of crank bar, and I also explain the logic behind that, why the cranking of a bar has to be done and all. So again I'm not going to explain it here. The MEP, after once all the let us once everything is done, you have put a beam reinforcement, you have put a slab reinforcement and all. Next now it's the time for the MEP people, that is mechanical, electrical and plumbing engineers. They will come to the place of slab to be casted, and if there is any electrical conduits to be put up, if there is any cutouts to be given, or if there is any plumbing works to be done, those things will be done by those people. Because see, what we do is a bare structure, right? Once the structure is done, we want people to stay there. If people want to stay there, they need to have electricity, they need to get water, and all, right? So for that what will happen, these guys, we require the help of this guy, that is mechanical, electrical and plumbing people. So wherever there is electrical conduits going, let us say for fan you have to put the connection and all, right? For tube light connection and all we require. So those guys will come, and wherever they have their separate drawings, electrical drawings, we'll try to see that electrical drawing. Yeah, yeah, this is the electrical drawing, it's mentioned here. So this is the electrical drawing. Okay, so all these are the points for the fan, these are the point for the fan, and this is a junction, this is a junction here. From this all this connection will be taken, all this connection will be taken and pass through this particular beam. So when the slab casting is done, they'll come and try to chip this portion a little bit, so that they're going to get this junction point. Okay, so this is how electrical drawing looks. Okay, so these are the cutout, you can see here open, right? So these are called as cutout. So to give a cutout and all, right, you cannot you will not do the casting here, this will be open. And this is a lift portion and all. So this is how this is the staircase portion and all. So this is how we are going to do. So those people will come, and if any work is there in their scope, they are going to do that. Yeah. So before the concrete is placed, the quality checks are done by the quality engineer, like checking the cover blocks, slab centering and beams are free from the clutters, etc. The slab centering and beam bottoms are also checked so that they can carry the load coming on it during the casting of a slab, right? See, because slab casting is one of typical work. See, all the load will come on the slab only. From slab, it will be transferred to the beam, from the beam to the column, from the column to the footing, from the footing ultimately to the soil. So beam is slab is one tedious work, and also it is a critical work, right? A small mistake here and there will result in a collapse of a structure. That may result in a collapse of a structure. So always whenever we do the casting of a slab, we should be more alert, so that the things will not go, out of our control. So that a proper checking has to be done. We have to try to see whether the shuttering has been given properly or not, whether the props are properly spaced or not, right? All these things we have to check. Along with that, the quality checks, like let us say your beams should be clean, you should not have any waste papers or debris and all into that. Those things has to be checked. Whenever in work in the big companies, all these quality checks will happen. So this checks has to be done. I forgot to add one point here. So before the slab reinforcement, before the slab bars are put up, we try to apply shuttering oil to all the shuttering, beam bottom and slab centering. And also nowadays what they do is they put up this polythene sheet, and over the polythene sheet they put a kind of carpet, so that what will happen, there is a good bond between the concrete and that particular carpet, and you're going to get a rough surface. So this is what we practice nowadays. We put a polythene sheet, and we put the first we apply oil to all the shuttering plates and centering plates. After that, we put a polythene sheet, and over the polythene sheet we are going to keep this carpet, right? You get a carpet in the market, I don't know what do you call that. So those things we are going to apply, I mean those things we are going to put, and over that we are going to lay the reinforcement, and over that we are going to do the concreting. So this is the usual practice what we follow these days. Yeah, once this is done, the amount of concrete required for the slab is calculated and ordered from the batching plant. If you're working in a big project, we order it from the RMC plant. Or if you're working for a smaller project, a machine mixed, local contractor will bring the concrete mixer, and from there we are going to do the casting of the slab. Yeah, once the slab is casted, immediately the curing is done for the next 14 days. See, once you're done with the casting of the slab, you have to do curing immediately with the help of a ponding process. Or ponding is like you create small bunds, and over that you're going to pour the water. Otherwise you can place gunny bag and then do that. It's up to you what you want to follow. But always remember, slab curing has to be followed for 40 days, because again slab is a critical element. A small cracks here and there in the slab will result in leakages and all. So usually what we do is usually what we have to do is we have to always do the curing of slab for 14 days, so that enough strength is gained in the slab. Next is the slab centering plates are removed after 3 days and props are refixed. Yeah, the props are refixed. So what do you mean by this? See, once you've done the casting of a slab, it's not that like for the footing and all, what we do immediately next day we the de-shuttering. Whereas for the slab and for the beam bottom, we are not going to follow that method. The IS 456 2000 recommends you that if you are doing a slab centering, the slab centering plates has to be removed after 3 days. And if it is a beam bottom, then the beam bottom has to be removed after 7 days. And as soon as you remove those slab centering and beam bottom, it will refix the props. So it's written here, props are refixed. These props are refixed, and the beam bottom is removed after 7 days and props are refixed. The de-shuttering for the beam sides, beam bottom, and slab centering plates are mentioned in IS 456 2000 code book. And if the span of the beam and the slab are larger, like let us say up to 4.5 meter, you can follow this. If it is greater than 4.5 meter up to 6.5 meter, there is a certain clause mentioned in the code book that we try to follow. But usual practice is what we do is after 3 days we try to remove the slab centering, I mean slab plates, and we try to refix that particular prop. And beam bottom we try to remove after 7 days, and will try to refix it. And after up to 14 days we are not going to do anything. Up to 14 days all the props will remain in their position, and only after 14 days we'll try to remove everything. It's mentioned here, the complete de-shuttering will start to happen after 14 days. Up to 14 days we are going to keep all the props. We're not going to remove any props, because we don't want any load to be transferred to the slab, because your slab has not gained enough strength, right? Usually what happens is after 28 days it will gain that much amount of strength. Let us say M25 is the grade of your slab, so that 25 Newton per mm square of a strength will be gained only after 28 days. So up to 28 days we need to keep it. But due to the what you call speed in the construction, and due to the superior quality of the materials that is available, and due to high grade of a cement, that is 53 grade of a cement, usually what we do is after 14 days we try to do the de-shuttering. Will happen after 14 days. And usually it requires, if you're constructing a big building and all, usually I require 4 to 5 days to do the de-shuttering. So it requires 4 to 5 days for complete removal of all the props, beam bottom, sides, and slab centering. So let us say today you are done the casting of a slab, so you have to wait for 14 days for those props to remain in their position. And after 14 days we'll try to remove the props, and it requires me 3 to 5 days to remove all the materials from that particular slab. So that once you remove all the material from that particular slab, those person, that is a brickwork persons, and the people who make this block work and all, they can come and start their work. So let us say you require minimum 17 to 18 days for that area to get clear once the slab is casted, right? So next is, once those things are done, again the same procedure will be followed. Once your slab is done, let us say you're done on your first floor slab, and you construct G+4 building, again second floor, third floor, and fourth floor has to be constructed. In case of residential building, then again the same procedure will happen. Again you have to raise the column reinforcement to the next floor, that is up to the second floor. Again you have to tie the longitudinal bar and the lateral ties. Again you have to place the preparation of the column starter for the first floor, followed by the column shuttering, concreting, and de-shuttering. So again, this whatever I explained you, the same thing will follow up. since it's a residential project, you have to just lift up the floor, right? First floor, second floor, third, fourth, and so on. So the procedure remains the same. So this is how we are going to do. So the same activities will follow again till the last floor is completed. Let us say you want to construct up to G plus 5. Again, whatever I explained, let us say up to the first floor I have explained. Second floor, third floor, and fourth floor, and fifth floor, the same procedure will happen, right? Yeah. Yeah. So what all are the drawings that you need to refer? Already I've explained. Once is that you are going to get an architectural plan. In architecture plan, you're not going to get what is the dimension of your column and all. Only thing is you're going to get, let us say you want to construct a 3 BHK house. So you're going to get the details of 3 bedroom. That this is the length of your bedroom. This is the breadth of your bedroom. You're going to get the dimension of your bedroom. You're going to get the dimension of your kitchen, utility area, living room and all. So you're going to get a plan of your particular building. So that is the architectural plan. And sometimes you'll get the orientation of the column also, where the column will come, where your column is going to come, and what is the orientation of your column. And you're going to get the details of your room. Let us say how many bedrooms are there. If it is a 3 BHK, you'll get 3 bedroom, one hall and one kitchen, and where your utility area and all those things we are going to get in architectural plan, right? Other than that, you're not going to get any information regarding the grade of a concrete, regarding the dimension of your column, regarding the size of your beam, regarding the depth of your beam, regarding the reinforcement. All those things you're going to get from structural drawings. So those structural drawings are, first is you are going to get the footing layout and reinforcement details of the footing, followed by column layout and reinforcement details of a column, followed by plinth beam layout and reinforcement details of a plinth beam, and all the typical floor beams and slab details you are going to get. These are the typical drawings usually what we get. Other than that, again, along with that, you will get a staircase drawings and reinforcement drawing for the staircase. This is usually what we get. Other than that, you have some other, like let us say you have a septic tank and you have some UG tank and all. Those are the different thing. When that depends from project, that depends on the project that you're working. But these are the typical drawing. Usually if you want to construct a house, these are the typical drawings that you're going to get. Yeah, I hope this is understood up to here. And happy learning. Keep learning and keep growing, and you're the creator of your own destiny. We'll see you back in some other video. Thank you.